British Mathematical Olympiad Round 2, Problem 1. So let's see what's the problem. The problem is the following. A positive integer n is called good if there is a set of divisors of n whose members sum to n and include 1. Prove that every positive integer has a multiple which is good. So let's consider small example of n. One of the important idea that is useful also in IMO is to consider a small example. So when n equals 1, so 1 is good because you can write 1 equals 1. 2 is not good because the divisors of 2 is 1 and 2, and you can't write 2 by using its divisors including 1. And again, 3 you can write it by checking a small example. You can understand that if n equals a prime number, it is not good because the divisor is 1 and p. If you use 1, 1 is not equal n, and 1 plus p is not equal n as well. And we continue. When we check 4, 4 is not good, 5 is not good, 6 is good. 1 plus 2 plus 3. 7 is not good, 8 is not good, 9 is not good. Now, we can conclude that when n equals p to the power of alpha, it's not good. Because if you write the divisors including 1, for example, 1 plus p to the r1 plus 2 plus p to the s1, then if you consider it, and consider the remainder of it when divided by p, we will see that it is congruent to 1 mod p, and it cannot be equal to n. So when p is a prime number, p, any power of p is also bad. And also 10 is bad, 11 is bad, 12 is good because 1, 2, 3, 6. If we consider 6 and 12, we will see, okay, we substitute 1, 2, and 3 for 12 and then 6. So we can consider that when, for example, some number is good, 2 times of that number is also good. 13, 14, 15. 2, 19 is not good, and now 20 is good. 1 plus 4 plus 5 plus 10. Now, we know that 5 is not good, but 20 is good. Why? If we consider, we can write 5 in this form, 1 plus 4. So if we consider 5 times 4, we can write 10 plus 5 plus, and we need 5 here, and we know that we can write 5 in this form, 4 plus 1. So here we considered 20, 4 is the divisor of 20, so we could write 20 in this form. 20 is good, so multiple of 5, we found multiple of 5 that is good. So let's check the other numbers. 20 is good, and also again we can say 40 is good, and like this we can say 2 when m is good, 2m of that number is good. And now again, we don't write this in our paper exam, we're just checking our ways, our methods to reach the answer. Now, we want to find a multiple of 7 that is good. We write 7 in the base 2 binary. If we consider binary display, binary exhibition or display of 7, we can see that we can write 7 in this form, 1 plus 2 plus 4. So we need 4. If we consider 4 times 7, 28. We can write 14, 7 plus 4 plus 2 plus 1. Now we found the idea how to find a multiple of n that is good. We want to write it in the classic form. For example, we want to write in our exam papers. So let's see. We say when r is good, when r is odd, if r is greater or equal to 3, you can write r in base 2, 1 plus 2 to the a1, because r is odd, so we have 1 and plus 2 to the a1 plus 2 plus 2 to the ak, and we consider maximum of a1 and ak to to ak, and we now consider a variable b that is greater or equal to this maximum. Now, like 7, we wrote 7 in base 2, 1 plus 2 plus 4, and we multiplied 4 and 7. Now we want to use that idea. We consider 2 to the b times r. We can write it 2 to the b minus 1 times r plus 2 to the b minus 2 times r plus 2 plus 2r plus r. And plus the last r, we write it in this form. And if you add up these numbers, you will reach 2 to the b times r. So we proved for 2 to the b times r. And now if you consider some number, for example, n equals an odd number times 2 to the m, we proved for large number you can choose a b that is greater than m, and we proved that for b that is greater or equal to maximum of these terms, it's true. 2 to the b times r is great. From some b that the all numbers that are greater than b, the number is good. So we can find b that is greater than m, and it's good. So we proved for when r is when the odd part of the number is greater or equal to 3. Now let's check when r equals 1. So we know that 3 is 6 is good. Okay, so we know that 3 times 2 to the k is good, like the previous proof. We know that when m is good, 2m is good. Why? Because we can write 2 times m in this form, m plus 1 plus 2 to the b1 plus 2 to the bl, and then we can prove it. Let's see here what we have. Let me move this part. You can write it when we find m, and m, for example, when m is odd. Also you can write it, you can substitute it with, let's delete this one. It's not, it can be any other divisors. For example, when m is good, you can say that m is good, so you can write it, for example, C1 plus CK, and all of the CI are divisors of M. And now you can write 2M equals M plus 1 plus C1 plus CK. Now it's true. So when M is true, M is good, 2 times M is good. Now we know that 6 is good, so if R is odd, then N will be, R is 1, N equals 2 to the K. So we know that 6 is good, so 6 times 2 is good by using this conclusion, and it's 3 times 2, it's 3 times 2 to the 2. We know that 3 times 2 to the power of 2 is good. So we've solved for all numbers that they have multiple that is good.